So, we know you guys just love lab reports more than anything, so we're going to give you 2 in 1 week. You're welcome. We're going to be talking about friction. We're trying to answer the question, what is that relationship between the force of friction on an object and that object's normal force, the force from the surface acting on that object? By now, y'all should be able to answer the hypothesis and do anything you need to with that part on your own. So I didn't give you anything to walk you through. All I'm giving you right now is our essential question and the 2 data tables we'll be working with. Yes, I said 2. We have 2. We have one for static friction and then one for kinetic friction. Now, because of just the way the laptop's working, this is what we'll give you now. In a minute, you're going to see the apparatus and the procedure, so just leave whatever space you need or put it down in a different order. Who really cares? Doesn't matter. Also, you'll notice that my data tables are really messy and lazy. I don't have all the stuff I need right here. Didn't use a ruler. It's past 4:30 on a Tuesday, and I don't really care that much right now. So y'all's will be better. I'm being a little bit lazy, but luckily y'all don't get to grade me. Sorry. All right, so get this down, pause the video, get everything you need. See you in a minute. Hello again. So here's our basic setup. We have this, which you're all familiar with. We have our force probe and our LabQuest. Then we have this dinky little cart. This is what we're going to be pulling back and forth on some surface that looks like this, so one of the lab tables, to figure out the coefficient of friction. We're going to be moving towards finding the coefficient of friction between this surface and this surface. So the basic procedure, you're going to have some of these, one of these, and a triple beam balance, which is not shown here, but you still want to include that in your apparatus. We're still going to use it. You're going to figure out the total mass of this thing using your triple beam balance. That's going to be recorded somewhere, just kind of off to the side. But then what we actually care about is the normal force. Now, by now, you shouldn't have any trouble using the mass of this to figure out the normal force from the table onto the cart. But since you're doing a calculation, since you're dealing with forces, since that's part of your data taking process, you've got to talk about that. You've got to show that. So you need to have a free body diagram somewhere in your apparatus where you talk about the forces acting on this right now, and then justify how you're getting the number over in the normal force column. Justify how you're taking this mass and turning it into a normal force. Do that, all will be well. So we've got our stuff on there. We got everything set up. Now we're going to get 2 numbers, 2 entries in either data table using just this one setup. So I suppose we'll start off with our independent variable, kind of small. So small mass, small normal force. We'll measure the mass of that, get the normal force. Then we're going to go over into the graph mode. Now it's going to be kind of tough to get these numbers sometimes. So you probably have to take it more than once. Just be ready for that. The first thing we're going to do, press play. And so now we can pull, and it's going to tell us the different forces as time goes on. Now it's not calibrated very well, but once it's done, now we can see those spikes every time I pulled it. We can see what's happening there. We can see the necessary, the numbers that we got that we needed to pull this. Start off at any old value. We play, and then I pull, watch what's happening to that number. It's not getting any bigger. It's getting bigger, the thing's not moving. And so that wasn't actually any useful data. All I've shown is that I wasn't pulling hard enough to overcome the maximum static friction and get it moving, so I do it again. I pull harder, 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 harder. All of a sudden it stops moving. That value right there is your static friction value. So you tap right up there on the LabQuest, you'll tap a few times. That force, that maximum value right there, that's the force that you had to pull to beat static friction. So over on that data table, make sure they can see that. Over on that data table for your static friction, in the same row as whatever the normal force was for that cart, you're going to record that value for static friction. Now, I don't want to throw too much at you all at once, but you can actually do that in the same trial. Pull, 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 it starts moving. Now it's moving at a constant speed. That's going to give me the kinetic friction as well. So just from that one thing, just from that one setup with the one normal force, I can get the maximum static friction. And then this value right here, since I was pulling it with the constant velocity, that value is kinetic friction. Now, again, realize free body diagram, you've got to justify why that is. I'm telling you why it is. I'm telling you that's the truth right now. You need to justify that in your lab report. Go through there, figure out what the value is, realize there's a little bit of wiggle room right there as it goes up and down. There's a way to account for that. We have those error bars. You will account for that when you actually take the data on Friday or Thursday or whenever we do this. But now, using that one thing, we've got our normal force, we've got our maximum static friction, and then we've got our kinetic friction. Lather, rinse, repeat. Add on more mass, take off more mass, whatever. Measure it with the triple beam balance, figure out the normal force, record that, and then get the static friction, and then as it moves at a constant velocity, as constant as possible, you can get both those friction values. The static friction up at the very peak, and then kinetic friction in the as flat as possible wiggly stuff right there. That's pretty much it. Get the procedure down, try to understand what we're doing here. For your apparatus, remember it's very important that you include how and where you're measuring the variables in that picture. Do the best you can on that. And that's about it. See you tomorrow.